Hello guys, and welcome back to a brand new machine learning tutorial. In this video, we'll be looking at implementing the mathematical equations we derived in the last lesson into our actual machine learning program. So let's begin. First off, we want to import the pandas library, okay? So we're just going to write import pandas as PD, right? Which basically means we're gonna be grabbing every single method within the pandas library with the terminology PD. Okay, so it makes it so that we don't have to write pandas all the time. Instead, we can just write PD. So down here, we're gonna transform these values that we've just created right now into a data frame. Right now, we can just see the tuples separated by a comma. It's a list of tuples, and you can see they're relatively linearly correlated, and they have a positive trend upwards. Okay, so if you wanted to make this into a data frame, we can just say df, which is just short for data frame, is equals to PD. Then we're going to grab the data frame method within the pandas library. We're going to say pd.dataframe, and then we're going to pass in the values. Okay, write values, and then we can write df.head. So this is basically our data frame. Okay, this is a quick synopsis of not a quick synopsis, but just the first 5 rows in our data frame. As you can see, they're numbered 0 to 4 over here. And to make this look better, we can just say columns is equal to the first column being x and the second column being y, to make the table, to give the table's columns headings, right? So now it's easier to understand what's happening within this data frame. Okay, so now that we know how the data frame looks like, we want to separate the x values from the y values. So how we can do that is we can just say x is equals to df square brackets, grab everything within the x column. Okay, that's how we write that. And to grab everything from within the y column, we can just say df y. Okay, so if you want to just print y right now, we should see 3 4 3 3 4 3 5. We can see 3 4 3 5. That's what we expected. All right, so to see how this data would look like on a graph, we can use a very handy library called matplotlib, which basically stands for mathematics plotting library. Alright, so after we've imported this, we can simply draw a scatter plot by saying plt.scatter x, the x values, and then we're going to pass in the y values. Alright, so we should see a scatter plot of all the values in our data frame, or in our list of x and y coordinates in this list called values. We can just see a quick scatter plot of those digits. To find the loss, we first need a prediction from our machine learning model. And to find that prediction, we first need a linear equation, which is in the form of y predict. We can just say y pred to keep it short, which stands for y predicted is equals to m multiplied by x plus b. Okay, and just above here we can make values for this. We can say m is equals to 3, and then we can just say m being the gradient and b being the y-intercept. We can say b is just equals to 1.2. Alright, because just like from eyeballing this equation, you might say the equation might look like that. So to draw this line, we can simply say plt dot plot first start off with the x values, then you would say the y predicted. Okay, now scatter brings you a scatter plot with the individual points on the graph circled with a blue shade. However, the plot function draws a line, as you will see if we run this block of code. And as we can see, our graph is way off. So one way we could improve this is maybe by saying by like reducing the value of the gradient. And we can see the line is looking a bit better, but we can make this better. Let's try and make the gradient to be 1.5, and we can see it's getting closer, and we can go to 1 again. Ooh, now that's looking really good. And then we can go to 0.3 just to see how that would look like. And now we are way off. I think 1 was much closer to the line of best fit. All right, so this is basically what our machine learning model will be doing. It will be changing the values of M and B until it achieves the line of best fit, or where the cost will be at its minimum. So to begin us off with, we can just say the loss is equal to the y value minus the y predicted. Okay, this is the loss. Okay, for each value of y, for each actual value of y, it's going to be subtracted from what our machine learning model, which is currently just this basic looking model, the machine learning's prediction. Okay, so we can just let's just import one extra library. This is the last one, I promise. Import numpy. This will basically help us with our statistical measurements, such as the mean and that. So to find the average loss, or let me show you what the loss would just look like if I were to print it like this. It would be a list, because each value of x, or each actual value of y, is being subtracted from each prediction. So if I was just to print loss, it would look like this. However, this doesn't really help us. Okay, we would like a sort of summary of all these numbers. So what we can just say is we want the mean. So we can just say numpy, which if imported as np, we can just get the mean method from the library, and then it'll just it'll just spit out one value, which is the minus 0.349. And one thing to remember about our loss function is that we don't want it to be as low as possible. Okay, what we want it to be is we want it to be as close as it can be to 0. Okay, that's what we want. We don't want it to be the least number. You can't say something like an error of -50 is better than an error of 1. Okay, that doesn't make sense.